Okay, so I'm kind of pumped to see what you put in number 3 here, and we're going to look at it mathematically or tabularly on the board behind us. We're going to look at the number of correct guesses I get in a row. So we're gonna build this up from the bottom to until we get to the p-value of less than 1 in 1,000. Because this is the report p-value that was gotten. The chance of seeing what they saw was less than 1 in 1,000. Now, why am I flipping coins instead of just going straight to the video, or straight to the study, excuse me? Well, I mean, because the null hypothesis is that the rate of learning disability is the same for hypertensive and non-hypertensive kids. The same. That's the null hypothesis belief. Well, that's like flipping a coin, because your chance of being right or wrong on a coin flip is 50-50, equal rates. So the question is, assuming equal rates, how likely is it to see that small of a probability? Well, let's work through this. Let's work through this, case by case here. Let's suppose, I guess on the first flip, I don't have any pennies in front of me right now. I guess on the first flip, the least number I could get correct in a row is 0. Like I flip and it's heads and I say tails, or, oh, here's a penny. I'll try it right now. I just dropped it. Heads. Oh, it's tails. So there you go. I got it wrong. What's the chance I get it wrong? Well, hopefully it's pretty obvious. It's 50-50. It's a half. Cool. Now here's where it gets interesting. What's the chance I get 1 correct guess in a row? Now what's a little bit goofy here is 1 correct guess in a row means I get the first one right, then I try the next one and get it wrong. So I have to get the first one right, which happens half the time, and then I have to get the next one wrong, which also happens half the time. So that particular outcome is going to happen 25% of the time, or 1/4 of the time. I have to first survive the first guess, which happens half the time, and then I have to fail the next guess, which happens an additional half the time. Okay. What about 2 in a row? Well, hopefully you see the pattern. I have to get the first one right, which happens half the time, then I get the second one, which happens half the time, and then I can get the third one wrong, which happens half the time. So hopefully what you're seeing is these little fractions are just going to continue becoming half of each other as we go. Now, 0.0001 is 1 in 10,000, excuse me. It's 1 in 10,000. We are nowhere near that yet. So let's keep going. 3 will be 1 in 16. 4 will be 1 in 32. 5 will be 1 in 64. We're still not really close. 6, I gotta make another column here. Number of guesses in a row and their probabilities. 6 will be 1 in 128. Okay, we're like 1/8 of the way there. 7 will be 1 in 256. Okay, we're getting a little bit closer here. 8 is going to be 1 in 512. We're going to start challenging Sean's mathematical ability here now. 9, 1 in 1024. That's good. Okay. 10 is going to be double that. 1 in, or half that, I guess. 1 in 2048. Whew. 11, out of space again, because this isn't going to get there. It's going to get close to it. 1 in 4096. Goodness gracious, I need another column. Number of guesses in a row. What's the chance? All right, so let's do it. 12. Okay, 12 is really close. It's 1 out of 8,198. If I did that right. Did I do that right? 8? No, 2, excuse me. 8,192. And then 13 is actually going to go past that. Well, technically speaking, it's less than, right? So that's going to be 1 out of 16,000. That's going to be a 4, that's going to be an 8, that's going to be a 3, I think. Okay, so at somewhere between 12 and 13 correct guesses in a row, we see that likelihood. Fan. That's ridiculous. That's ridiculous. because I'm making this video in week 6 and you're not taking this homework or taking this quiz until week or doing this homework until week 8, I don't know what you're going to put down for your answer number 3. But I'm curious if anybody went as high as 12. My guess, based on similar asks of my in-class students over the years, when I ask them similar questions to this, they usually get to about here. And once it gets past 1 in 32, which is just around 3% or 4% or somewhere in there, that's when they start getting skeptical. Like, you're getting too many right in a row. You're getting too many correct in a row. I think something's up with the way you're guessing. In other words, it doesn't look like you're guessing anymore. So what they were doing in the study was very, very similar. Now, I want to drive home the point, before we go back to the original study with hypertension and learning disability, I want to drive home this point. I kind of figured this was going to look kind of like this, so I built an Excel simulator to repeat this experiment so you can actually see these numbers kind of grow organically as opposed to just taking my word for it. Let's take a look at that next. Okay, my friends, so here I've built basically a simulator in Excel that is generating 2 random numbers, one for the coin flips right here and one for what I am predicting. I put that in quotes because we're assuming I'm guessing. And if you actually look at the cells that are driving these, they're both rand betweens, 1s and 2s. So it looks like I've got 1 equaling heads and 2 equaling tails. So right now, in this particular situation, I have guessed incorrectly. I have not guessed correctly the coin flip tails and I guessed heads. So that would be no correct guesses in a row. So I'm going to restart the experiment and try again. Okay, that time I actually got 2 correct guesses in a row, and then I failed on the 3rd. So I got coin flipped heads, I guessed heads, yay. Coin flipped tails, I guessed tails, yay. And then I got it wrong on the 3rd. So that's 2 correct guesses in a row. That was no correct guesses in a row. That was also no. That was no, and this is going to take us a good long time. There's 3. I keep saying 4. It's 1 less than what you see because the last one is me getting it wrong. So that's 3. That's 0. That's 1. So this is going to take a while. So what I propose we do is we simply grab a stapler and we hold this puppy dog down and we let it do its thing for a good long time. And I will go get some more work done and I'll come back in a couple hours. And we'll see what the graph of this thing looks like and how it compares to what we did. Well, you can actually almost already see it matching up to what we have on the board. Before we even let it run, I'm going to let it run because I want to see some more of this fill out. But you can see this bar right here is hovering right around 50%. This one's hovering right around 25%. That's right around an eighth. That's right around half of that or a 16th. And it looks like an exponential decay curve, doesn't it? And it looks like we actually are picked up, I think the most we've gotten so far is a 10. But I'm going to let this thing run a bit more. I think we need more data, and then we'll come back. Okay, my dear friends, I didn't let it run for hours and hours and hours because I just realized that I need to cover a colleague's class in about 20 minutes, so I better get this thing wrapped up. So anyway, it's kind of fun to see the graph kind of filling out. It's a little hard to see what's going on down here because those numbers are very, very small, as we kind of predicted they were going to be. So I'm going to go ahead and just move this graph out of the way so you can see the probabilities. And there they are. There they are right there. Okay. And notice how close they are to what we kind of predicted they were going to be. We predicted this one at 50%, and it's hella close. 25%, hella close. 1/8 or 12.5%, very, very close. 6.25%, very close. 6 1/8%. They're right around where they should be, about 1.5%, about 3/4%. They're very, very close to what they should be. Where it gets interesting is when we get down into what we thought was going to be the rarest one. Now this, I love this so much. Check this out. This one right here is still above 0.0001. Not much, but a little bit. 0.00193. It's almost about twice as big as it should be, as crazy as that sounds. This one right here is it's just a touch under 0.0001. It's 0.000096, which I guess would round up to 0.0001. And we haven't seen a 13 yet. So if I let this thing run enough, eventually it would get up to 13, 14, and eventually I would be able to guess a number of them correct. But you can see what's happening. If I'm guessing at these coins,
I'm not going to get very many in a row. Half the time, I'm not going to get any right. 75% of the time, I'm going to get one or fewer correct. 87% of the time, I'm going to get two or fewer correct. 94% of the time, I'm going to get three or fewer correct. About 97% of the time, I added too much. 97% of the time, I'm going to get four or fewer correct. Around 99% of the time, five or fewer correct. About 99.234% of the time, I'm going to get six. Most of what is going to happen down here. This is where the true guessing, or if you're looking graphically, these are where the true guessing results are happening. I'll change them to a different color. Here, I'd say I'm guessing. Here, I'd say I'm guessing. Here, I'd say I'm guessing. As we start moving further and further out in the tail, it becomes increasingly harder to believe that I'm guessing. As a matter of fact, as I told you before, most students would draw a hard line right there between 4 and 5 and say, you know what, anything more than 4 and I think you know what's going on. So that means those 5 bars right there are kind of the null hypothesis distribution, the guessing distribution. Anything to the right of it would imply I'm not guessing. Let's see how this corresponds to the hypertensive versus non-hypertensive and learning disability article.